All right, this is the third and final video in the polynomials section where we're going to talk about adding and subtracting polynomials. Again, watch the first and second videos before you watch this one, just so that you're sure you know all the pieces of polynomials and the words that we're going to use as we go through this lesson. So the first thing we'll look at is adding polynomials. All right, now even though polynomial is a new word for us, we've already added polynomials before. We added them way back at the beginning of the semester when we first learned about like terms, whenever we were looking at both sides of an equation or an inequality and trying to simplify them. We added like terms. That's all we do for adding polynomials. So we're going to add like terms. Remember what like terms are? Like terms have the same variables with the same exponents. And we add like terms by combining their coefficients, keeping the variables and exponents because that's the type of term it is, but we just add the coefficients to get the new coefficient on the term. All right, so let's do an example of adding polynomials. Again, you have already done this. We've just never called it a polynomial before. All right, so let's do some examples. Let's add the polynomials 3x squared minus 3x plus 6 and 5x minus 1. Okay, so let's go back to the very beginning and notice that these are both polynomials. They count as polynomials. There's some terms added together. Sometimes those additions look like subtractions because the coefficient is negative, but they're polynomials. And specifically, these are both polynomials in the variable x. All right, so if we want to add them together, we just need to identify like terms. So let's go term by term, decide what type it is, and if there's anything like it. Okay, so this first one is an x squared term. If we look at our other terms, I don't see any other term that contains an x squared. So 3x squared is just going to have to be by itself. We can't combine it with anything. All right, now let's go to the next term, negative 3x or minus 3x. We need to look and see if we see other terms with just an x in it. And we do. We see this one. So these two terms are like terms. So we're going to combine their coefficients and keep the type of term it is. So if we combine minus 3 and plus 5, we get plus 2. So whenever we combine these two terms, we end up with plus 2x. All right, so those are done. Now let's look for other like terms. Our next type of term is a 6. 6 is what we call a constant term because it has a degree of 0. And this is also a constant term. So the 6 and the minus 1 will go together. When we combine those, we get a plus 5. And we just added those two polynomials. That's all it takes. Identify like terms and combine them just like we've done before. All right, let's look at another one. Okay, so this will be part B. And in this one, we have an x to the 4th minus 2, and we want to add it to negative x cubed plus 4x. Can we see that? Negative x cubed plus 4x. There we go. So just like before, we're on a hunt for like terms. So let's go term by term and see what's alike. Well, this first one is an x to the 4th. Do you see any other x to the 4ths here? I don't. So x to the 4th stays like it is. Next term, negative 2. That's a constant. Do we see any other constant terms? I don't. Negative 2 stays, or minus 2 stays just like it is. Next term, minus x cubed. We see any other x cubes here? I don't. So it has to stay like it is. And finally, 4x. We see any other terms with just an x on them? I don't. So it's just going to have to stay like it is. So there were no like terms. So we just write the terms together. We just add them up, but they all have to stay separate because none of them are alike. We can't combine them. So that's adding polynomials. Something we've done before. We're just using a new name for it. All right, now let's look at subtracting polynomials. We've done this too. We just didn't call it that. All right, so to subtract a polynomial, let's start with an example. Let's say we want to subtract x squared plus x plus 1 minus x plus 2. All right, so we have a polynomial in x minus another polynomial in x. All right, we talked about the distributive property before whenever we wanted to subtract several things. That's what we're going to do here. So you can think of this a couple of different ways. You can think of it as distributing the minus throughout that second set of parentheses, so minus x minus 2 and changing it to a plus. Or you can change this to a plus and just change the sign of everything in here. It's exactly the same thing, no matter which way you choose to do it. It just depends on how you like to think about it. Personally, I like to distribute. So what I'm going to do is take this minus and distribute it to the x and to the 2. And then what we end up doing is adding. So again, you could think of it as just adding the opposites of everything that are in that set of parentheses. Same idea, depends on whether you like to distribute or not. And now we're back to where we were a second ago, adding like terms. So let's look. We have an x squared. No other x squareds to combine it with. So it has to stay by itself. Okay, so next we're looking at terms with just an x on them. No, that's a like term, right? Isn't that just an x? So those are going to be like, and that's it. But let's look at it. If we add x and minus x, it would be like doing plus 1x minus 1x. And if we put those two numbers together, a plus 1 and a minus 1, that's a 0. So we don't really get anything there. If you want to go ahead and write 0x, you can, but you can just leave it off too. And then finally, we have this type of term, just a number. Well, this is also just a number. So we can combine those two to get -1. And that's the sum of your polynomials. In this case, it was a difference, but the only real different thing that you do here is make everything in the second polynomial, whichever one's being subtracted, make every term in there the opposite sign. And then you just add like normal. So you can leave it like this if you want to. There's nothing wrong with that. But typically, we wouldn't want to leave the 0x in. So we just get x squared minus 1. Okay, let's do one more of these. All right, so let's say we want to do 4x plus 8 minus 5x squared minus 2x minus 12. Okay, so we learned last time in the last example that subtracting polynomials is just like adding polynomials. You're just going to add the opposite of everything in the second set of parentheses. So this first set of parentheses is going to stay exactly the same. And we're just going to add the opposite of everything in the second set of parentheses. You could just as well think of it as distributing a -1. Either way gets you the same result. So now we're on the hunt for like terms. And it doesn't matter which way you do this, you just might end up with a polynomial that's kind of out of order if you don't start with the biggest exponent. I'm going to start with the x's. It's fine. Okay, so the first term I see has just an x. Let's look at all of our terms. That one also has just an x. So these two are like terms. So we can combine them by combining their coefficients, in this case by adding. So it's going to stay an x term, but if we combine 4 and plus 2, we end up with 6x. All right, next type of term I see is a number. So we look for terms that are just numbers, and I see this one here. So I can put those two together. 8 plus 12 is 20. And the only term I have left is this 5x squared, and there's no other x squared to go with it, so it can't be combined with anything. So it just stays minus 5x squared. All right, and that concludes the polynomial section.